So with that, let's go ahead and do the first exercise. So in Python, you can get a computer hostname by using the import socket and then type hostname equal to socket get hostname. I want you to modify the hello world program so that it will print out a physical hostname where each individual process is located, and then test your program using 2, 8, and 16 processes. The outcome should look like this. Bing bang bing bang, get hostname. MPI run, that's np equal to 2. So it should print hello world from process 0 running on host 0038. And if I go ahead and I run it on all 16 cores, you can see that half of my processes from 0 to 7 running on node 0038, and the other half is running on node 0301. Yep. So typically the specific, you can see that all the processes from 0 to 7 is bound to the first node, and all the processes from 8 to 15 is bound to the second node. Open MPI bind processes to the physical in a sequential fashion. So basically, it will try to fill up all of the local core first before trying to use the core from additional node. The reason for this is in computer communications, anything that is internal is always faster. You have core talking to one another within the context of the same machine. It's going to be faster than cores trying to talk to one another from one physical machine to the other. So it tries to bound things to the same cores. You can force round robin binding. So basically that means that you have one going to the first node, and then the second process go to the second node, and so on. It can be enforced by putting it and then additional flag called map by PPI n node, with n is the number of nodes per physical machine. The time when you want to do this is, let's say when you have I/O heavy processes and you want to read and write from the local hard drive, and you only have a single local hard drive. So if you are running two processes, it might be better to have each processes trying to read from two separate hard drives rather than to have the two processes trying to read from the same hard drive. So this is another command that you can try, MPI exec, that's n equal to n, and then map by PPI equal to node. What this means is, I want 16 cores. I want my MPI program to run with 16 cores, but I want to map a core per node. And try to rerun the Python program with the round robin binding.
Why do we use exec instead of functions?
Sorry, MPI run and exec are equivalent. You can choose use one or the other.
So then why is it like n instead of p?
Sorry, which one?
The small n flag, it was np before?
Also, again, I don't know why they have that many flags to do the same thing. You can do N or NP. What was this flag? Page. Oh. sorry. So for example, in this case, I have two nodes. Each node have 8 cores, but I only want to have my NPI processes. I only have 2 processes, and I want each process run on a single node. So by doing force processes one per node, I get 2 of my processes running on 2 separate nodes. If I run this command without the map by PPR, you can see that 2 my process 0 and 1 is running on the same node.